Okay, so welcome everyone to today's webinar, which is on predicting customer churn using open source technologies. My name is Lewis Fogden, and I'm a consultant from Keyrus, and this is hosted in collaboration with Dataiku using their DSS platform, and it's on Amazon Web Services. Okay, so before we get into things, I just want to quickly go over the agenda. First, we'll have an overview, so we'll talk about what exactly the problem at hand is, how we're going to approach it, and what a solution might look like. We're then going to go into why we should use open source technologies for such a problem, and why it's really a good time to be an open source right now. We'll then go on to the platform that we're using, and that is Data Science Studio by Dataiku, and talk about how that can actually accelerate a data science project. Finally, we'll go into the solution itself, which is a live demo. And if we have a little bit of time at the end, I'll briefly mention Keyrus and give some tips and tricks for churn and productionization. Okay, so the problem at hand is that of a telecoms provider who's trying to reduce churn or increase customer retention. Of course, reducing customer churn is important for any business, but especially in businesses which use subscription models or fixed lengths and have high costs of customer acquisition. It's really important to reduce churn, because otherwise, without contract renewal, you can yield really low or no profits. Now, I'm not going to go into all of these statistics. The slides will be sent out after the presentation, so you can look these up or follow the sources yourself. But let me just draw your attention to one or two. So firstly, that it costs about 5 times more to acquire new customers than it does to keep current ones. And secondly, that the probability of selling to an existing customer is pretty good actually, 60 to 70%, but selling to new prospects is considerably lower at 5 to 20%. And that stark difference outlines how important it is to keep your existing customers. How exactly do we go about that? Well, the most kind of obvious or standard way is to deliver targeted offers, or sometimes even just customer service calls to your customers at the right time. Vincent later on is going to go into a little bit more detail about what exactly the right customers are. Okay, so what kind of data do we have that might be relevant to this problem? Well, we're going to have our customer details, and that's your typical data you have in a CRM system. So your name, your birthday, your gender, some telecom specific data. So have you recently got a new phone? Do you have any applied package extras? That sort of thing. We'll also have some customer consumption habits, so the number of calls made, how many minutes you used, that kind of thing, and perhaps a little interaction with the vendor themselves. So what was the last reason for a call to your internet provider or telecoms provider? In a kind of less simplified project, we might also have some details about, is the client on a family plan or multiple person contract? What kind of phone do they have? Perhaps we even have insight into their data or app usage. And we could even take some unstructured data from social media feeds about the customer themselves. So what kind of approach might we use to solve such a problem? Well, this approach isn't strictly limited to churn or telecoms, but is more of a general data science workflow. Of course, first we define or frame the question of interest. What is the churn propensity for any single customer to leave us? We'll then go about extracting our data from our various source systems. So that could be your CRMs, your ERPs, your transactional systems, social media feeds, etc. We're then going to combine and integrate that data. In this case, it means joining via our client IDs. We're then going to do some exploratory analysis and start cleaning our data and extracting our relevant features. Once we have those features, we're going to fit some simple statistical models and make predictions. And based on some evaluation criteria, we'll determine which of our models is the best. The next point is really the kind of most important of any data science project, and that's to iterate and refine the previous steps. You can add new sources, you can integrate them in different ways, you can do more feeding, and you can really determine which features are actually relevant to your models. You might also change your evaluation criteria and refine your parameters or hyperparameters. And then once you have a model that you feel can offer value to your business, you can output your results, and we'll look at how you might output them a bit later. The final step, which is where a lot of people struggle, is actually the deployment to production, going from a sandbox dev data science project into something which is running day in, day out for your business. And what might that output look like? Well, the kind of more standard way of doing it is to feed your high priority and your risky customers, those with a significant propensity to churn, into either maybe a CRM or BI tool for your customer service representatives, so they can deliver targeted offers via phone or perhaps email, or into some kind of automated distribution system for your communication channels. So that could be email, SMS, web app, or a mobile application. Okay, so we know a little bit about the problem at hand. Let's talk about why it's a great time to use open source technologies and how they can benefit such a project. The first point really is paramount to the nature of open source, and that's that it is fully transparent or fully auditable. Because you can dig down to the most granular level, this allows you to be sure of your results and avoids kind of black boxing or placing trust in vendor claims. Of course, not everyone will dig to that level, but you can be safe and assured in the knowledge that you can. That kind of leads quite nicely to our next point, and that is quality. For popular libraries such as Pandas or scikit-learn, they're maintained by hundreds or sometimes thousands of contributors from around the world, often from leading global companies. And that means that security issues, bugs, and etc. are kind of quickly updated. Your updates are frequent, and that extensive community usage ensures quality. It also means that you have a lot of people to reach out through on forums such as Stack Overflow for help or issues. Our next point is customizability. When you're using a more proprietary tool, you often have to put a request into a vendor to add a little bit of functionality, or kind of do quite convoluted steps in order to extend. With open source tools, it can be as simple as pulling down the library of GitHub, forking it, and adding the code that you need to adapt it to your particular client needs. And due to all these things, you have real agility in your business when you use open source technology. Of course, you'll have some kind of procurement process at your company, which might limit the speed at which you can get things in. But especially in a more sandbox dev environment for data science projects, it can be quite easy to take advantage of the newest packages, libraries, and techniques. And that really gives you the agility to experiment and quickly solve problems. And quite importantly, find the right toolkit for your business and your team. Due to the popularity of open source tools, you can really leverage a lot of existing skills, both within your company or the larger development market when you use common languages. Obviously, Python, R, and Scala stand out a lot for data science projects. The use of these technologies is definitely in an upward slope. When you look at stuff like the Stack Overflow trends, you can see that young developers and university students are increasingly using these languages. And even traditionally closed companies, so your IBMs, your Microsofts, and so on, are participating in the community and open sourcing their own products, as well as integrating open source offerings into their products. And finally, you have cost. While I won't say that using open source tools is necessarily free, it certainly can help minimize licensing fees compared to major vendors, especially if you're using multiple libraries or multiple products in your stack. So different applications for your ETL processes, your modeling, your visualization, etc. And my final point about open source is just that it's a really good time for machine learning in particular. You have existing libraries such as Python scikit-learn, mlib, mllib even, H2O, or the rather infamous XGBoost, kind of providing these production-ready algorithms for common machine learning tasks, so your regressions and PCAs and clustering, k-means, etc. And that means you really don't have to reinvent the wheel. You can utilize the existing libraries that have seen deployment in countless projects worldwide and have earned their names and their places. Okay, so now we know a little bit about why open source is good. How exactly does that fit together to solve our problem? Well, when you're kind of developing any project, you really have three major options. On the left here is the custom code approach. And what that means is writing your application more or less from scratch yourself. Of course, you're going to be making use of open source libraries, but I mean hard coding it essentially. And that delivers a really flexible, highly tailored solution to your problem with a large talent pool to pull from. But it's going to result in long development times and essentially long time to values. And that's kind of best for large scale or novel problems. That's how these libraries get created in the first place. Over on our right-hand side, on the opposite ends of the spectrum, you have our proprietary software stack. And that means using kind of the more traditional enterprise applications with pre-built functionality, and that gives you really quick time to value, and is usually done through a GUI or graphical interface. The issue is that there's kind of a black box. You don't necessarily understand what's going on underneath, as well as a small talent pool, which can mean large recruitment costs. Of course, licensing and port fees are per product in your stack. And then today we're going to be talking about really the kind of combination of these two, something down the middle, which is the concept of an open data science platform. This is a single enterprise application which combines open source libraries and languages with enterprise features. So those features can include your both code and visual interfaces, industry standard data source connectors, cleaning and blending tools, scheduling, and team collaboration. And while there's a variety of platforms out on the market today, and they are not open source, they are proprietary, you can use a single licensing cost and have access to all of the latest open source technologies through a more user-friendly interface, shall we say. Okay, so let's talk about the platform we're using for today's demo, and that is Dataiku's Data Science Studio. So as I said just a few seconds ago, DSS is an open data science platform. So it integrates technologies and libraries from Python, R, Spark, SQL, and a load of the Hadoop stack with those kind of enterprise features that you need in a production environment, such as LDAP security, versioning and audit logs, scheduling and monitoring tools, and quite importantly, the ability to deploy real-time prediction services using a REST API. Okay, so while I don't go on forever on PowerPoint, I'm just going to jump over to DSS, which is our live demo, and talk you a little bit through our customer churn project. So here on the landing page, let me just draw your attention to a few things. First of all, on the top left, we have just the name of our project, and you can see that me, the little monkey with a coffee pot on his head, and my colleague Leo have worked on this project. You will see a brief description and what exactly we've been editing recently, so within the past 3 hours. If you look down a little bit more, you'll see the contents of our project. So we have 16 different data sets, 12 recipes or kind of transformation or ETL steps, and a visual machine learning model. We also have a couple of notebooks full of code, as well as a dashboard available in our project. As DSS is designed around team collaboration, you can see we also have some notes on the bottom left and a to-do list. If we come over to the right here, you can see our timeline. So this is different things which we have done through the whole history of our project, and that can be creating a new model, reloading a model, having a new recipe or transformation step, editing a dashboard, or any such thing. And finally, to further encourage team collaboration, we have our comments. And so I can just go over here and maybe pass an important message or not over to my colleague. Okay, so let's leave the landing page for a second and go over to the kind of visual overview even of our project. And this is called the flow screen. So the most important thing about the flow screen essentially is that it essentially runs left to right. So on the left here, you'll see 3 little up arrows in blue, and they are our data sources, our customer consumption, customer details, and customer call reasons that have been uploaded into Data Science Studio. As we traverse to the right, you'll see a variety of transformation steps and models before we output our predictions on the right-hand side here. And those are our customers segmented by their churn propensity. So our kind of priority risk and fairly risky customers. Now, don't worry, I'm going to go into this in a bit more detail, but that's the brief overview from left to right. Okay, so let's click on our customer details here. And first of all, we want to do a bit of cleaning to ensure that our data is actually of a good quality before we fit some kind of statistical model on it. If we go over to the lab here and go new visual analysis, create, we'll be immediately presented with a sample of our data. For those of you familiar with Excel or perhaps SQL Server, you'll recognize the tabular or panel data format, where each row represents a single client or customer, and each column represents a feature. So the thing that immediately stands out to me here is the email column. If you look in this bar, this features a lot of green and a little bit of red. This indicates that actually some of our email addresses don't conform to a kind of typical email address structure, so there might be something wrong with them. Let's go over to the left here and add a transformation step. If we go to find and replace on our email, a common error is that we've actually have spaces somehow have entered our email addresses. So let's just replace our spaces with some empty strings. And you can see actually that was all the issues we had with our email field. However, email isn't exactly a useful feature to have when we're trying to predict churn. Every customer is likely to be unique, and so it doesn't tell us much. However, maybe the domains might be a bit more useful. So let's just do that. Let's open this contextual menu and split our email addresses into both their local parts and their domains. As we said before, the local parts probably aren't useful as they're likely to be unique. So let's just delete this column and keep the domains themselves. When we look at our other columns that might be useful, we can see we have a birth date in our data set, which is in an unparsed format, essentially a string. Let's try and calculate something that might be a bit more useful. So first, we can go down here and parse the date. You can see that DSS has automatically detected the format and knows that all of our rows actually conform to this format. And now from here, we can do something useful, such as working out the age of each of our clients. So let's compute time since, set the output time unit in years, and we can just call our column something like age. As most machine learning models only accept generic input, it's important that we don't try and pass in data types, such as our date, and we convert them into a more useful format or data type. Okay, so let's just jump back to our flow by going up here and clicking on this little icon. All of the steps that I've done before, plus a couple more, are wrapped up in this nice little yellow option called our prepare statement. You can see that we've similarly prepared and transformed our data from our customer consumption data file. And as we get to this step here, you can see we have another icon, and in this case, it's a join. So what we're doing here is that combination of our data sources and to get them into a single tabular format. For those of you familiar with SQL or perhaps Tableau, you can see that we've simply joined our data from our free sources on our client IDs. Let's just have a look at what result that might have in our customer all. If I go to explore, and you can see that for each client, not only do we have our customer details as before, but as we scroll to the right, you also see our customer consumption from our other data source. Okay, so now we have our cleaned and integrated data. Our next step is splitting it into both a training set to train our machine learning models and a testing set to evaluate them. Using the split icon here, we simply split them into training and testing randomly with a 30-70 ratio. And so we can apply some form of machine learning model to our training customers. Now, although we have an existing one in this project, I'm just going to build a new one from scratch to show you how simple this can be in DSS. So again, let's go up into our lab, but instead of clicking on prepare data, we're going to use a quick model this time. And we want to make a prediction for our churn value. Let's choose our target variable as our churn column. And you can see on the right here that we have a couple of options for our backend. Now, DSS has a visual interface to a number of libraries, such as Python's scikit-learn and XGBoost API, as well as mllib and H2O. At the moment, we only have Python installed on this demo application, so let's go with that. We have various templates that we can start from. So let's go into our insights template. That takes a couple of models which it thinks might perform well on this data set and uses those to compete against each other. Now, I'm just going to click train here. What this is doing is going to train 4 models using our estimator columns. Now, you might be wondering, why exactly did it decide to use a decision tree, a logistic regression, and various other model types? And what about our parameters and the encodings of our variables? Well, this can all be set in Dataiku if we go up to the top right on our settings here. But by default, when you choose a template, it can use some default values, and that's what we have here. So for those of you who use Kaggle, it probably comes as no surprise that our gradient boosting algorithm has actually done very well. If we scroll down, we can see our evaluation metric. In this case, by default, it chooses the area under our receiver operator curve. And it's done quite well compared to our other models. We can also see that our gradient boosting algorithm has selected our most important variables, and that the number of calls and the average call length are fairly important, as well as whether the person has a recent smartphone. So let's just tick that so we can actually say, let's use this model compared to the other three in our actual flow. So if I go back to the flow for a second, you'll see here that we have our training customers and 3 green nodes. The first trains our model. In this sense, is the gradient boosting algorithm. The second represents the model itself. And the third is an evaluation or scoring node, which will then take our model and use it against our test customers. You may have also noticed a couple of orange nodes with the Python logo here on the bottom. Now, as we don't have too much time, I won't go into these, but if I click on details here, you'll be able to see a little preview of a code notebook. In this case, it's using scikit-learn and particularly the random forest classifier to create a new model. Now, while DSS has a variety of libraries it can access through the visual interface, by using the code nodes here in our actions, so that could be Python, R, Hive, Impala, Spark, we can actually access a huge range of open source tools. Okay, so what exactly does that look like, our output? Let's go to our customers, which have been scored with our visual model. Click on Explore, and we'll slowly scroll over to the right here, where the columns will have been appended. For each client, we have the probability that it's false, essentially that they won't churn, the probability that it's true, how likely they are to churn, and our prediction, which will essentially just be either 1 or 0, true or false, depending on a particular cut-off point on the probability. Our final stage here, with regards to our models, is to choose which of our models, either the visual one, which Dataiku generated for us, or the one which we coded ourselves in Python using the random forest classifier, is actually the best. So if I click on here and go to details, you can see that we'll select both of those data sets, combine them, and work out which had the best area under our receiver operator score. It will then output those best predictions further into our pipeline. Our final stage is actually just to split our customers this time based on our churn propensity. And we split them into 2 different data sets. The first is our priority customers, those with over 90% churn propensity, and our risky customers, those with a little bit less, between 70 and 90%, who probably still need to be contacted, but perhaps aren't the top of the list of our customer service representatives. Now, instead of opening these data sets directly, I'm going to go over to our dashboard. Now, there are a lot of ways which we could output our data, such as injecting the data straight into a CRM or BI tool for our customer service representatives. But in this case, we've chosen to use DSS's charting engine itself. Here you can see our priority customers on the left and our risky customers on the right, as well as various informations about how a model is performing. So variable importance, our confusion matrix, precision recall, and so on. We also have a refresh button here, so that every day someone can come in and rerun our model in order to keep it up to date and relevant using the newest data. Okay, so I'm just going to go back over to our PowerPoint here. Don't worry if that went a little bit quickly and didn't cover too much depth, as Vincent will be going into 2 client use cases on our next presentation. I'm just going to skip these slides quickly. They were available simply in case my internet connection to the server failed, as you all know what live demos are like. Okay, so I've just got a couple more minutes, so I just want to say a quick few words about Keyrus, if you're interested. One more thing first. So you saw the kind of technological means in which we implemented our churn model, despite it being rather simplistic for the course of this demo. But really, to actually get value out of any data science project, you really have to act on transforming your business on 3 different fronts. Of course, we have the technology, and that means deploying secure, maintainable, and scalable solutions that are integrated into your existing stack. And productionizing analytics so that your information is actually a strategic asset. It's really made use of. However, technology isn't everything. Without your staff actually embracing and adopting analytics as part of everyday operations, the technology won't drive any change in your business. And the thing that's binding them together really is the processes to make sure you put in place best practices for the adoption, the maintenance, and the support of your technology. And through these processes, you can start to create value through new data science use cases and new economic models. Okay, so just a few words about Keyrus, as of course, this is a presentation. We're a major player in consulting technologies that are located most of the way around the world. We have 3 main pillars, but the one we're going to be talking about today is data intelligence, and that can include big data and analytics, data science, business intelligence, information management, as well as training external companies. We're also a partner of some of the most innovative companies in the kind of technology space. Of course, Dataiku up there on the left. And when we send out the slides later, there will be a variety of references a bit more specific than this, detailing customer churn. So if you have any questions at all, please just come over to me, email me, my address will be in the end, and we can talk about those churn cases and how they might apply to your problems. Okay, so I am just out of time, so I will leave the tips and tricks for the handout. If I just pass you over to Vincent, and he will take you through 2 customer use cases who use Dataiku to solve their churn needs.
Thanks a lot, Lewis, for the presentation. So let me just switch the screen share up. Yes, so hi everyone, I'm Vincent de Stocklin. I work at Dataiku as a partnership manager and deployment strategist. Maybe a few words as an introduction. Let me just check if, okay, I think we're good. So yeah, just maybe a few words of introduction on Dataiku. So we're, you know, a big startup now, I would say. So we were created 4 years ago with the ambition of developing a data science platform to help, you know, basically companies build and deploy predictive applications in a more kind of efficient manner. So we've seen a good success, you know, in Europe, in the US as well, and we're basically addressing, well, a variety of use cases. Of course, churn is one of the kind of priorities when we're talking about churn analytics. But you know, essentially, you could address, and I saw in the kind of the questions, things about fraud detection and so on. So we do a number of different use cases across industries with companies that are essentially, you know, moving towards more machine learning, more predictive analytics. So happy to discuss, you know, potentially more use cases if you're interested. So today's focus, as a, you know, kind of a build up on what Lewis was presenting, of course, is about churn detection and activation. So essentially, what, you know, energy and processes companies will put into making sure that their clients don't, you know, cancel their subscription or, you know, stop buying products. So the short, you know, presentation that I will make will be basically around presenting 2 live use cases that we have where clients have built and deployed churn detection applications, as well as to give some, say, best practices or insights in terms of, you know, each step of the way. How can you actually make sure that you're, you know, in the best kind of position possible in order to make this project a success? So Just before we start with the two use cases, I want to kind of take some time to explain a concept when it comes to predictive applications and building and especially deploying predictive models. So the way we see things, of course, quite traditional, is that you will always need to articulate the design side with the production side. So essentially, in companies that we see, the design will be kind of the data science team or the customer analytics team working on either sample data or kind of a sandbox environment where they will be able to access data sources, explore, clean, build models. So essentially all of the process that we saw in the demo with Lewis. And once you get to that point where you have this workflow that fits the initial requirements, and or that you have the models with the correct performance that you're looking for, then the trick, and there's still a big challenge on the market today, is, okay, how do we deploy this? How do we turn this kind of prototype workflow model into a production-ready application that impacts directly the processes of the marketing team, customer reps, and so on. So what we've done and what we've tried to do with DSS is actually to help clients address this articulation between design and production worlds. And this is done through, say, what we call a node architecture. So essentially, you will have a design node in your kind of development environment. And then you will have production nodes, and those are two types, and this is kind of the key concept that I want to differentiate. So essentially, you will have two ways of deploying a, let's say, predictive application in production. The first way is kind of the scheduled batch workflow where each new partition of your CRM data or weblog data will run through a workflow such as one that you saw, will be scored by a model, and then that the workflow will write into, let's say, a SQL database or operational database on which is plugged, let's say, an emailing tool or something like that. So you will have kind of batch refreshes of those scores, those predictions being output into an operational database. That's the first way, and essentially this is kind of the more classical or traditional way to do it. The other way is actually not so much about deploying a workflow, rather than actually deploying a model onto an API server so that you can do real-time scoring. So the traditional kind of use case that you could think about for this is not so much churn, actually, although we will see an example where this logic has been implemented, but it is more around projects such as fraud detection or product recommendation, where based on the behavior of a given client, we will send a query to the API, and this will retrieve in real time the score that this transaction is actually a fraud, or the ranking of our different offers on a website for a given client. So essentially, those two modes of deployment are possible. And it depends more on what you're actually trying to achieve in terms of who's using the output of the model and in what way, in what situation, and this will be what helps you to decide between, okay, am I doing kind of a batch scheduled deployment, or am I doing a real-time API server deployment? So I just wanted to make this clear before we go on to the use cases. So the first use cases that I want to talk about is for a European startup which is called Coyote, which basically, so they used to sell devices that you would put in your car, but now they're mostly mobile app based. So essentially, when you're in your car, it's kind of a Waze meets I don't know really what actually, but they alert you when there are police roadblocks, or when signalization is changing, or speed limits, and so on. So it's kind of a co-pilot that helps you when you're in your car, to see if you have roadblocks ahead, or you have kind of more congestion, and so on. So the thing is that they're on kind of a monthly subscription model, and they have a big part actually of their user base that can cancel their subscription. So the average kind of duration of subscription is about 9 to 12 months, which is not a lot actually. So they have this big challenge every month or so to actually be able to identify for their loyalty team, okay, who are the people with the highest risk of actually canceling their subscription, and how should we potentially address them, right? So what they've done basically in the product or in DSS and with their team is to build basically the whole end-to-end workflow, going from raw data, which in this case is essentially the customer device data. So in this case, it's mobile application logs, as well as some internal CRM data and some customer service data. So it's quite traditional in the sense that they didn't really add any external data. They don't have huge challenges in terms of working, for instance, with geographic data and so on. They've mostly been focused on, okay, I'm going to look at what makes sense in order for me to anticipate churn. So is the person using his device or not? And how is he using it? Is it just about receiving the alerts, or is he participating in actually generating the content for the rest of the community on the application? So essentially, we went through kind of a step-by-step process where, of course, the first step is always about data cleaning, combining the different data sources. So of course, in this example, whereas our kind of unique key for analysis is at the customer ID level, but some of the challenge here, and we see a lot of this when we work with kind of log data, or we're trying to reconstruct patterns and behaviors across many different points, is what we call sessionization. And I'll go into a bit more detail later, but it's really this notion of how do you figure out how to build the relevant features? Is it, how many minutes has the person used my application in the last month or 3 months, or how many times has he actually logged in, or what's his average? So what are the right features that actually influence churn or no churn? So it's kind of a creative, iterative process here in terms of enriching and creating the features for the model. So here the models that we used in this case were mostly random forest at the beginning, just to understand and to iterate on the various features, because it's quite straightforward, it's quite robust. So if you're kind of looking for the right features before optimizing your model, random forest is kind of a good friend. But in the end, the one we went with for performance was gradient boosting, because it's quite appropriate when you're trying to do things around, basically ranking, right? Which is, in this case, this is what we're doing. We're ranking the whole customer base according to the propensity to actually cancel their subscription. Once we developed that model, one of the key was really, okay, how do we make sure that first it is scheduled and automated in order to feed us the relevant predictions at the right time, but also how do we make sure that this process has some internal controls and validation so that the performance of the model doesn't drift over time, or that we don't have sudden drops in performance. So what we implemented is essentially advanced scheduling with metrics and checks, where you can implement scenarios such as, okay, look at the last partition of data. So this is potentially my last month. Run it through all of the data preparation workflow where we were adding new features to our existing customer behaviors and so on. And then retrain the model and benchmark that performance against what we've seen in the past, right? And if that performance is still above a certain threshold, then output the corresponding predictions into a database, right? So the database that we were using for most of that computation, except the machine learning part, was HP Vertica, which is very powerful when you're trying to do, at scale analytics. So it's a massively parallel database. And this, the output of the predictions were, basically directly fed into a SQL database where the CRM tool was plugged on. So the idea was that every month around the 15th of the month, the loyalty team would get updated predictions with kind of a ranked spreadsheet of all of the clients, and then they would target outbound call campaigns to the most risky customers. And so the metrics that we have here are, so what you can see on top here, top 10% are 3 times more likely to be actual churners. So this is a measure that we call lift, where essentially, and we see that a lot in churn examples or fraud detection, for instance, where essentially you will have a human team with a given capacity to either look at fraudulent claims or call churners. So it's about changing the way that they actually choose the ones that they're going to call, from either very simple business rules or even just a random sample, and actually helping them with an algorithm to have a list or 10% or a cluster of their population where the number of true churners or true frauders or true positives in any case is much higher than kind of a random sample, right? And and so this is the metric that you can see here, where in this top 10% that they're calling every month, they have 3 times as more actual churners. And the, of course, end metrics in terms of kind of business impact was the call campaign efficiency, which is plus 11%, and that was calculated in terms of how many people are we actually encouraging to prolong their subscription. So yeah, just maybe a word on the team. So this was built, so Coyote initially didn't have a lot of internal skills in terms of data science. So we helped them with this first project, but they're not now quite autonomous. And this was built in 2 months by a team of 1 data scientist and 1 analytics manager, BI guy, who really knew the data assets and so on. Now, so this is a good example of, let's say, a classic batch kind of churn application. The second one is for an insurance company in France, where the process here is a bit different. Unfortunately, it's we can't give the name of the insurance company because there's too much information on the, the use case. So essentially here, the process is a bit different because it's not so much about anticipating churners in order to make an outbound marketing action. It's more about, while the client is in the process of canceling his subscription, which happens over the phone, it's more about giving insight, real-time insight to customer reps to allow them to first understand better why the person might be leaving. Second, try to understand in terms of promotions what he might be interested in or receptive to. And of course, if the person is still intent on churning, can we still propose other insurance products given his profile, given the history of interaction, and so on? So it's more kind of machine learning augmented customer service with a specific focus on making sure that we still get value, or that we get value in those last instances where the customer is canceling his subscription. So here the data was a bit more heterogeneous because we have a lot of unstructured data, namely text based on history of interactions, of course, history of prescriptions, and so on. So we have all of the client's historical data, which is of course anonymized. There is a web portal that the insurance has where there's a lot of behavioral information. How many times does the person connect to his client kind of account? What does he look at? What is he receptive to? What type of operations does he do, and so on? And we also have a lot of panel and survey data, which helps to kind of give some perspective on those behaviors and those customer profiles. So here essentially it's more or less the same kind of initial steps, I would say: cleaning, combining, and enriching the data. Here there's a lot more interaction data, right? So it's less about how many times have you used this in the past years, but interactions between different people inside the kind of ecosystem of the insurance. So doctors, clients, prescribers, and so on. So we used graph techniques in order to actually calculate, proximity between different types of actions. And since there was also a notion of what is the next best product or next best action in terms of retention, it's also about scoring all of the different possibilities. So this is something that is greatly helped by using interaction graph techniques. Now, in terms of output, as I mentioned, this actually needs to be a real-time system, because once the person calls the customer service, then it's about taking some of his historical data as well as some, contextual data. So the first few questions that the customer rep will ask will be, okay, why are you not satisfied with the service? Or what type of other products are you looking for, and so on. And given those answers, he actually feeds that into a form that is then sent to the API, and that retrieves specific insights. So in that case, customer ID, some of the contextual information that he has over the phone, and then the information that is retrieved to him is, okay, a ranking of the reasons why this client might be canceling for, either price or what we call life event, so he's moving somewhere and so on. Depending on this, there is also an API with a specific model that does next best promotion, right? So given the type of client and what we've observed in terms of palatability to promotions, the customer service rep also has a ranking of all that he can propose to him, and in what way those might be interesting or not to the client, because there are very kind of complex coverage systems across professional insurance, personal, family, life insurance, and so on. So there can be quite complex articulations between those, and that helps the customer rep be much more focused in terms of his message, right? And of course, he also has potentially recommendation on what other products could this client be interested in. So the metrics that we're looking for here are, so of course, increased retention rates over the phone, by understanding more precisely what is wrong and what is right in the kind of relationship that we have with the client, increased cross-sell rates, so 5% across other products in kind of the insurance branch. And also one of the kind of added benefits that they saw was a better ramp up, so they have big turnover on the customer rep floor, so decreased period of ramp up and more customer service, more satisfaction in the surveys with kind of a customer service that was provided. So here, in terms of technologies, we used mostly, for the data preparation side, we used mostly Spark. So one of the advantages of the platform is that it allows you, even if you're not a Scala coder, to actually write data preparation, joins, and so on, and have that executed as Spark. For the machine learning part, we used both scikit-learn and R. R is especially strong in terms of packages for the say the graph side. And the team that we had here, one data scientist, one data engineer, mostly for connection to data sources and at scale data wrangling, and one analyst who was more on the, let's say, business understanding side, and kind of the logic of how do we integrate that afterwards with customer service applications. So in terms of the API nodes here, so those are individual clusters of servers that support high availability, load balancing, and so on. In this use case, it's not huge in terms of volume compared to some of the use cases that we can see. At peak activity, we get about 4,000 calls per hour, which is not a lot, but some of those APIs can be quite complex because several models are actually deployed on the same API node. So for instance, in terms of other products and next best product, there is actually several models per geography, so by, let's say, a French, not county, but department, by type of client, and so on. So the logic in terms of when the query is sent to the API can be sometimes quite complex. We also have here some advanced scheduling in order to back propagate new model when it's retrained, and to reduce the drift of performance. So if we take maybe a step back and go into some of the best practices, and I'm not going to spend too much time on this, but from design to production, at each of the different steps, there are some kind of key challenges and best practices that you need to keep in mind. So if we start with framing the problem, and Lewis kind of talked about this already, but what does churn mean for me? What metric do I choose, right? You first need to be able to have a metric that is kind of a target in the machine learning sense of the thing, but that also fits kind of the way your company does business, right? So first, subscription churn and non-subscription churn are completely different, right? If someone actually cancels a subscription, then it's quite easy to understand what churn is, right? But if it's more about, kind of a physical store where you will choose that someone not buying for a month or 2 months is actually your metric of churn, then that's fine. But you still need to have some business consensus around how do I define it and how do I frame my problem around this, right? Second thing is, if you're going to deploy it into production, then, and we'll go into more detail about this later, but you need to figure out how long in advance you will need to be able to anticipate, right? So for instance, in the example of Coyote, well, 15 days is enough. So they get predictions, mid-month, and they do all of the outbound campaigns in, the following week or 10 days so that people don't cancel at the end of the month. But if you're in a more kind of complex sales process, in insurance company, for instance, you might need to anticipate 2-3 months in advance. So in the way that we will train your algorithm and think about the activation, this will change a lot of things. And of course, you need to think at the very beginning, how will I activate this model? How will the solution, what I'm building, be used in production? Is it through, a database and then the CRM is plugged on top of this? Is this through an API? Who will be using the output of the predictions? And this is a common pitfall that we see in any machine learning project where, if you just hand out requirements to a data science team and let them play with the models, sometimes you may lose some of the fit with the actual solution that you're trying to build. So always have this thought out in the beginning, and business stakeholders along the project that actually check that everything is going smoothly, right? Understand the business. Okay, yeah. So of course, understand the business, design the solution involving the end users. Getting, cleaning, and enriching data. I won't spend too much time on this. Of course, one of the keys and the kind of buzzword around 360 view of the customer, this is key for churn, because you're not only looking at, is he using my service? You're looking at that plus socio-demographic, who he is and so on. But you're also looking at, what's the story of interaction in terms of customer service, and across all marketing touch points, how is he reacting? So this is something to take into account, and as much as possible, try to get as much data as possible. I was mentioning the challenge around creating meaningful features out of log data, such as mobile applications, websites, and so on. So you have a lot of techniques to actually do these things, like window functions, sessionization, but you have to know that it's kind of a creative and iterative process to go about figuring what is the right feature. Is it, how many times has he contacted me in the past 2 months or 2 weeks? So this is kind of a very iterative process. So getting predictive, of course, common pitfall, only give your algorithm data that will be available to you in production. So the small graph that you see is actually, how do you figure out how to build your train and your test data in order to make sure that, in production, you will only have data that's available to you, and that you've already got this, kind of anticipation period that makes sense for the business. Be careful of some features whose distribution change over time. So total purchases over the lifetime of the customer, that creates a big difference between some of the values that you have in your train and your test set, and it will create performance drift. As I was mentioning, focus on finding the right features, then fine-tune the models. No need to do XGBoost and deep learning if you're not sure, or at least pretty sure that you have the right features. Deploy and improve. So of course, it's not only about prototyping, but it is about production. So, how do you actually use those predictions. So Lewis was showing an example where you basically have two data sets, risky and priority. Usually the way we think about churn is this small kind of matrix that you can see. So essentially I play with my threshold. Depending on the cost of activation, I can be a bit more tolerant to, sending emails to even people who might be, do not disturbs, because it's only costing me an email in the end. So this is really depending on your business logic and cost versus revenue linked to activating a true positive or a true, like a false positive, and so on. As the output churn model, of course, we see a lot of integration with marketing activation, emailing, CRM, and so on. In that case, be sure to build feedback loops where you get, you can improve your model over time by making sure that, how did those predictions actually yield results? And of course, when you're doing scheduling, monitor the performance of the model. They're often drifts over time, and try to retrain and improve the model over time, either with new features, adding new data sources, and so on. Okay, I'm almost done. I guess we'll have 1 or 2 minutes for Q&A. You'll get the slides, but we have a number of resources around, churn, so tutorials, sample projects, and so on. So feel free to take a look at those and get back to us if you have anything. So that's the end for me. I guess we can maybe take some time for some of the questions. Okay, so question here: what are the major variables we should consider? Customer social activities, call centers. So, okay, that's kind of a broad question. So usually, all of what you're mentioning are potentially interesting features, average revenue, all of the social activities, calls to the customer service, and so on. So those are different aspects, I would say, or different potential data sources that you can address. Some customer service data, transaction data, social data, and so on. But what you need to think about when creating features is actually having this kind of time-based, is kind of a time-based logic, right? Where it's not about, it's not so much about, how many, let's say, tweets has he sent me over his lifetime. It's more, okay, in the past 2 months, what type of action of this type and this type has he done? How many times has he connected to this? How many times has he opened my emails? How many times has he connected to his online thing? What is the total revenue generated by him on this period, right? So it's more about framing those time-based features, but all of what you're mentioning can be considered in kind of a churn model. And then major value that will drive customers not to churn. This, I have to say, I'm not entirely sure how to answer. It really depends on your business. Some are very price sensitive, some are very quality of service focused. But in any case, just identifying them and getting on the phone with them in many cases is enough to prevent some of the churn. Other things you might not be able to do anything. Export to PMML for deployment, not today, no.
On the export to PMML, there's certainly no Dataiku functionality, but I have had a quick Google and someone has done it on this blog. So have read of that and let us know how it goes, I guess. I guess one thing to note about all of Dataiku is that because you have obviously the code nodes, you can essentially write whatever you want. So if you're writing a Python or R or a Scala, start my video. If you're writing a Python or R or Scala machine learning model, if you can export it to PML from Python, normally you can do it within DSS. So generally, not everything is available through the visual interface, but there's enough to have a really good go at things. But when you need that kind of extra functionality in that, you can resort back to the coding as you would. So DSS is really about kind of speeding up your workflows, using those, data source connectors, visualizations, getting things off the bat, having those kind of scheduling and real-time API deployment, those enterprise features. But anything that isn't included in the package, well, you have access to, your language of choice, essentially. I don't know if Vincent has much to add to that.
No, that's you're completely right. And yeah, I see the blog post. So not officially supported, but definitely always some workarounds for people who know how to code and who can get into the more nitty-gritty, I guess, of the platform. Are there any other questions? I see I don't know if it's really a question. Can run end to end, I guess. That's the point of the platform, at least if that's what you mean. It's really being able to go from raw data to pushing out predictions into the operational processes of the company. So I think okay. So I think we're done for today. If there are no other questions, thanks everyone for listening in. We'll send the slides, and you'll see some of the additional material in there. If you have any questions, feel free to reach out to us, and we'll be happy to take the conversation further. If you're interested in more kind of customer use cases, references, and so on, or insights, we'll be happy to share and discuss with you guys.
Cool. Thank you very much for attending, everyone.